polymer part, we already cover about what? We already cover about the synthesis, about the classification, effect of heating, the crystallization temperature, the melting temperature, the glass transition temperature, the degradation temperature, that 4 temperature point that we learn. We also learn about thermoplastic and also thermoset. And today we will learn about elastomer. Elastomer, another category of what we call elastomer, another category of polymer. Elastomer is basically a polymer that what we call that exhibit a polymer that exhibit rubber-like elasticity. Okay, a polymer that shows some rubber-like elasticity. So, for example, like the rubber that you have, this natural rubber, this thing. So this is the rubber-like elasticity. So another way to define elastomer is basically a material, a polymer that has high strain to failure. High strain to failure. Another way to define this thing is that a material that have a high strain to failure. The strain is basically how long it can deform before it break. Because for example like this, it can what we call deform more than its original. Meaning that it can deform, this is original, so it can deform more than 100% than its original. So elastomer typically have the what we call the strain rate more than 100% than its original lah. So how much it can deform this thing is that how much it can deform when stretched or ni lah. Okay, so that is basically a definition of elastomer lah. Example of elastomer, first is a rubber. So that example of that is basically a rubber. Normally the rubber come from the tree, the latex tree lah, the rubber tree. So this rubber tree, and when you sort of like scratch the tree, this thing, you get the latex. Okay, inside this latex you have this isoprene. Isoprene molecule, something like this. Macam ni kah? Macam ni, something like this lah. The isoprene molecule. They have a lot of this molecule, and you know about polymer, this molecule attach with each other lah. So that is isoprene. So for the rubber, to get this elasticity, why the rubber show this elasticity is because this isoprene polymer, or we call it more properly as polyisoprene, because we have a lot of this. Polyisoprene is very long. This polyisoprene is very long, to the point that it's entangled by, it is sort of like tangled on itself lah. It's tangled. It's very long. And it's tangled. So when you stretch the rubber band, what happens is that this become untangled. This become sort of like untangled like this. Untangled like that. The reason why it can behave like this is because there are weak, sort of like weak interaction between this chain and this chain. Okay, this chain and this chain. Between chain, there are weak interaction. They are not a covalent bond at all. Okay, so you have, when you put a load, this thing will sort of like unstretch, untangle itself. Okay, so that's why what make the rubber, you can sort of like pull it apart like this because of this thing. When you pull apart this jumble chain, it's like a spaghetti lah. Spaghetti jumble up lah. Jumble up will unravel and become this long chain lah. That's what make rubber is so stretchy lah. Okay, so that is one example of elastomer. Sometimes you see something behave like a rubber, but it's not a rubber. Okay, sometimes you see something behave like this, more or less like that, but it is not a rubber. For example, like this thing. Okay, so this thing, even though it's stretchy, but it's not a rubber. This is silicone. This is silicone. This is a silicone. The silicone here, the second example of elastomer is silicone. The silicone there, another example is silicone. Silicone. And this silicone, you need to put E there. Silicone, E. Because the silicone without E is the element itself. So you see a periodicity table. Let's say I open this thing. Let's see. Okay, let me bring there. Okay, so if you see there are silicone there. Mana? Okay, so you can, macam mana ni? Saya tak bawa ni lah. Okay, so from here you can see there are silicon. This is Si. Okay, silicon is the element. Silicon element with the atomic number of 14. So that is silicon. This is you have the E, silicon E. So it's totally different than the element silicon because the silicon this one is basically made up of this siloxane. Siloxane, what we call the monomer for this silicon. For a rubber, the monomer is this, isoprene. This is isoprene. For the silicon, the monomer is siloxane. What is siloxane? Siloxane is basically is something like this. You have a silicon, you have oxygen, you have silicon like that. Something like that. And then this silicon, where's my red? This silicon typically have the alkyl group. For example, CH3 or whatever lah. CH3 like that. So the siloxane backbone is this thing. This is the siloxane backbone, this one. The silicon oxygen. Okay? And then typically the silicon is connected with another what we call the R group or any other group. It can be this alkyl group, can be other group. So that is siloxane. If you have a lot of this, we call it polysiloxane. Polysiloxane. So another word for silicon is polysiloxane. Okay. So the silicon is basically a main matte polymer lah. So if you see the one that I pass around lah, that thing, the one that is what we call in yellow orange in color is basically come from this. This itself, even though the label is yellow, but it's not yellow. This thing is clear. If you look here, they say clear. So this is silicone paste. Okay, you can buy in Mr. DIY whatever. And normally people use a gun to take it out. This thing lah, cut this, put the gun, and then you not sometime. I mean it will coming out lah. So this one is basically clear. It's like clear lah, clear paste lah, clear paste. This also clear. Okay. So why you get this color? The color like orange in color is because I add a food coloring there. Add food coloring and then mix them, and then you get that thing lah. And then once you open this, if you open this, because I don't want to open here because it's quite messy. If I open this thing and then I have a gun, you know right, the choking gun, right? You push this thing out. The choking gun, I don't bring the mouse lah, so difficult, a little bit difficult lah. Choking gun. The name is choking gun. Choking gun. So something like that lah. So you got something like, okay, you got something like this, and then you put this here, and then you press the gun, and then it will coming out, and it will coming out clear. When it's coming out, it's not yet cured. It's cured at the room temperature. If you look here, the label, they said RTV neutral silicon sealant. This one, same thing, but this is RTV acetic silicon sealant. Let's look first what is RTV. There are a few types of the silicon. Where is the thing? Typically there are three major silicon type. The first one is HTV. This is basically high temp vulcanization silicon, HTV silicon. And then you have RTV. So that is room temperature, room temp vulcanization. And then you have L, liquid silicon, LSR. Okay, this is liquid silicon rubber. Okay, so you have this STV, RTV, and LSR. So STV, as the name implies, it will cure at the high temperature. RTV, it will cure. You learned cure before when we talk about the epoxy. The epoxy, we recap a little bit. Epoxy comes in two parts. When you combine them together, and you left it for a while, it will become hardened. That hardened part is, we call it curing. So you have the three types of silicon: STV, RTV, and liquid silicon rubber. So let's talk about STV first. STV is require high temperature to vulcanize, meaning that become hard. So normally STV silicon, they sell in a solid form. Okay, I don't have the STV here, but imagine this is the solid of the STV silicon. So they have this solid thing because STV silicon have high molecular weight, very high molecular weight, and it's also cure at high temperature. High temperature, meaning that you have something solid like this, and then, but the solid is not like totally like hard. It's like a plasticine. It's more or less like a plasticine. You still can play around that thing. So what they do in order to make it hard, I mean that to make it something like it's usable, is that they take this paste of STV silicon, and then they add some coloring if they want to color, and then they sort of like knead it, and they sort of like knead or roll it. I mean that macam it's like when you make bread, you need to knead it so that it will combine with the whatever color you add. So let me put here. So I'm not using the mouse, so not TV silicone. So you see, it comes in a paste like that. Okay, it's more like a solid. And then in order to make a mold, because let's say you want to use this silicone to make, for example, to make like a mold. Let's say this container is made from plastic. Let's say you want to make this container using the silicone. So you take this thing, and then you mix them with the color, whatever, if you want to add color, and then you put in the mold. Okay. This, but it's not liquidy lah. It's more like, yeah, it's like this. You knead it, you roll. So it's not liquid. So you cannot really pour like epoxy. Epoxy you can pour, right? You can pour in what thing. This STV, normally you don't pour. You need to use your hand to mold into the shape lah. You cannot easily pour like that because it's just like this. It's more like solidified, like this, solid. And then you put lah, if you want to make like a bowl, you need to put lah, like that. Okay, so that is a high temperature vulcanization. After you mold it, let's say you have this, let's say I take this picture. Okay, wash. Okay, alamak. Skip that. Okay, for example here, you can see there is like a mold. They want to make like a shape assuming this mold. So what they do is that they take the silicone, whatever silicone, and then they knead it here, and then the using hand, they just sort of like put on the mold. So if you go in front, do you have that? So okay, first they use the roller here to knead the, what you call, because if you use hand, it's very difficult lah. And then what they do? Banyak cakap lah ni. So it's just you just put like that lah. So that is HTV lah. And after you have all this thing, after the silicone is assuming the shape of the mold, then you take all this thing, you take out the silicone itself and put into the oven. Only then it become hardened, because now if you don't put in the in the oven yet, you can still play around that thing. It's like plasticine lah. Only after you put in the oven, then only then it's vulcanized. Vulcanized meaning that they are cross-linking happen, and then you get that thing lah. You can play, have this rigidity lah. Not rigid, I mean that you have silicone lah. I mean, I don't have that silicone thing, but yeah, that's how they do it. Room temperature vulcanization is like this. Okay, RTV neutral silicone, RTV acetic silicone. So the difference between these two is that if you use this thing, it's cure faster because it have the acetic acid inside. Okay, normally when you put acid inside this thing, they help to make this cure faster. Around like 50 minutes, it become like solid like that, like the one that Alif hold. Okay, so that is basically already fully cured. This takes time, maybe like 1 hour, 2 hours. Okay, why people use this compared to this is that you have more time to play around. This thing you need to work very fast. Okay, because if you don't work fast enough, then if you want to make certain shape, not even you get that shape is already hardened like that. The good thing about this is that it's fast lah. If you don't need to make a complex shape, then use this and it's enough lah. Okay, so that is room temperature vulcanization silicone. So this thing you don't need to bake it in any oven. So you press out using the chalking gun, and then you left it for a while, and then it become like that, hardened like that. Okay, so this is cure at room temperature lah, cure at room temperature. So still, this thing RTV silicone is quite a paste. This is it's like a paste like lah. It's not like liquid yet. So if I go here, RTV silicone, if I change this to RTV silicone, RTV silicone, so that the thing image, whatever. So if you go to Mr. DIY or whatever, you get this thing lah. So it's easy lah. You can just take it out and apply. It's only one part, because normally epoxy you have 2 parts. This only 1 part, because it's cured at room temperature. It doesn't need other thing. It doesn't need other hardener or whatever. It just, you open this, you pour it down, and then you get the silicone itself lah. Okay, so still this is like a paste. RTV silicone paste. Let me. Alah, semua gambar macam ni je. Proses. Semua dah like that. Tak ada proses ke? Tak ada gambar lah. TV silicone, bathroom. Semua gambar ni But anyway, what I want to say here is that this still a paste. It's very difficult for you to put it into mold. You can put into mold, but it's very difficult lah, because it's like a honey. It's more gummy or more sticky than honey lah. So that's the thing. So liquid silicone rubber is this thing. This thing is liquid. So this, this thing, if If you open this, you can see like it is a liquid. Yeah, it's a liquid lah. It's a liquid. So the advantage of this is that it can be poured into a mold. For example, a baby nipple, puting susu tu, puting susu whatever, they use this thing. Okay, or any silicone what? Silicone product, silicone for silicone baking. Any product that you see during the baking this thing, the silicone case or whatever this thing, they are made using this thing. Okay, because you can mold it easily. This doesn't cure at room temperature. That's why you don't have temperature here. It's cure. Normally this liquid silicone have this what we call another catalyst lah. This is what we call catalyst lah. By itself is still liquid. You add this, only then it start to harden, it start to cure. So normally what people do is that they have the cup and then they pour this thing, and then they pour this thing a little bit, depending on the ratio, and then only then they mix, and then they pour into the mold. And over time, because it's already mixed, the reaction happen, and then the silicone will harden, and then lastly you get something like this lah. So that is a liquid rubber lah, liquid rubber silicone. It's difficult because I'm not used to using keypad. Okay, so that is liquid rubber lah. So the advantage of the silicone is like it doesn't stick. Okay, it doesn't stick, and also it what we call, it can sustain high temperature. So an advantage of this silicone is basically first is non-stick. Non-stick. That's why you use that for baking. Okay, you baking, you can pour it, you can take it out, and so on easily. And secondly, can what we call have stable at what temperature? What temperature? Typically between -50 Celsius into 350 Celsius. Okay, so that is the stability, and also the ability is not stick. This doesn't stick. It doesn't mean that that silicone never stick to anything. This silicone can stick well to glass. Typically for glass, it can stick well lah. If you look aquarium glass silicone. Alah, saya gambar ni je. Okay, for example here, you can use this thing, whatever that thing, to make a seal. Another properties of the silicone, it can produce a watertight seal. Watertight seal. So if you go to the bathroom after this, look at the what we call at the inside the toilet, there will be some whitish thing on the side that what we call that join two part together, and you see the silicone is applied. Normally is what we call transparent in color. So any glass panel, when you combine, you can see a silicone, especially when they use this glass panel to put water inside, because silicone can promote this watertight seal. Okay, it doesn't mean that even though I say here non-stick to many surface, it doesn't mean that it will not stick to anything. It depends on the silicone that you use. Some silicone have good adhesion to the glass, some silicone good adhesion to certain types. So people change this, what we call this alkyl group, to meet their need lah. So some silicone is good for this, some silicone is good for that. But in general, this is the properties of the silicone. And silicone is the elastomer, another example of elastomer. So most elastomer here, rubber and silicone, is basically most elastomer is thermoset. Okay, majority of elastomer that you found is thermoset. For example, that thing, the one that I leave hole, is basically a thermoset elastomer lah. Elastomer is something can have a high strain, but it's also thermoset, meaning that it doesn't melt lah. It will degrade, but it doesn't melt. So you cannot reuse again. Once you make that, you cannot reuse, you cannot melt that thing again, and then do it other stuff lah. Alif, boleh sana? Sekejap, saya nak tunjuk. Okay. So this thing is elastomer because of this, but also it's the most set. The rubber band here, rubber is a natural polymer. Rubber is natural polymer. But the rubber here, the rubber that you see here, this one, where's the rubber? Where's my rubber? Tak ada Saya tak bawa rubber Oh, saya tak bawa rubber Tak apalah, saya guna rubber ni lah. Tak bawa rubber. Wait. So this rubber eraser, okay, I have the rubber eraser here. This rubber eraser is not a natural rubber. This thing is basically vulcanized rubber. The one that rubber band or rubber eraser is not manufactured directly from this, because the latex is the one that is like getas kerap tu lah. You cannot use much lah, because it doesn't have enough rigidity. It will sort of like crumple here and there. So the rubber band and rubber eraser is basically already vulcanized. We learned before, vulcanized meaning that you add something to the rubber. For example, like car tire, you add sulfur. So here also, this thing is already vulcanized. That's why you can hold it. You can hold this thing and you can rub the thing easily lah. If not, previously people used this latex, but this latex, when they use as a rubber eraser without any modification, first the latex is quite stinky. You know, the bau dia, the smell is not is quite bad, and also when you do as a rubber eraser, it will crumple down. So you have a lot of, it will not retain the shape, it will crumple. So in order to avoid that problem, people vulcanize that rubber and turn it into rubber band and rubber eraser. So rubber band and rubber eraser is already vulcanized. So it's not natural rubber, it's a synthetic rubber. Okay, rubber band, rubber eraser is not natural rubber. Natural rubber is the one that you get from the latex without any modification. The rubber eraser that normally that you found, there are many grades. This rubber eraser, even though the name is rubber eraser, this thing is not made from the rubber at all. This is a vinyl. Some rubber eraser, the old rubber eraser like this, rubber eraser. Okay, this one made from the rubber lah. The white one normally like this one especially for fiber castle, this is not from rubber at all. This is from vinyl. Okay, so even though it seems the same, but it's totally different thing. This synthetic rubber, normally the one that is blue and something like this is a synthetic rubber, but currently the premium rubber, the one that when you try to rub, it doesn't give a lot of debris, that is made from the vinyl, V-I-N-Y, vinyl eraser. Okay, so normally vinyl eraser is usually used as a premium grade lah. Nowadays, most of rubber eraser is actually vinyl eraser. But previously, most of rubber eraser like this, that's coming from the latex, the real latex lah. The real latex, the latex that's already vulcanized. The new one, more or less like Faber-Castell, typically is vinyl. Okay, so this shows that even though something we call it rubber eraser is not rubber at all. So knowing about the material, you know that a lot of name that's given to certain thing is not really actually the thing. Like this is vinyl, but they call it rubber eraser. People call it rubber eraser. Normally the one that's on your pencil, this thing, your pencil, and then you have this thing, that thing is normally the synthetic rubber, the one that's here lah, the real rubber eraser. The one here normally made from the vinyl. Okay. So as I said, most elastomer is thermoset. Okay, but there are also thermoplastic. There are also thermoplastic elastomer, because people try to develop this thing. because you know this thing, this what we call this elasticity have many use in life. But unfortunately, previously, you get this elasticity by vulcanization only. Vulcanization of this, what we call the silicone, or what we call the rubber. So people try to what we call to develop this thermoplastic elastomer. Example of thermoplastic elastomer is TPU. TPU is thermoplastic polyurethane. So that is an example of. Oh, I don't blink Alah, I always don't blink. Alah, saya tak bawa lah. I don't bring lah today. So later lah I show. During 3D printing, I show this thermoplastic urethane. So TPU, as you know before, polyurethane here. In the previous class, we learned this is coming. Example of polyurethane is your kitchen spoon. Kitchen sponge. Okay, example of polyurethane. And we show before we light up the fire, and then this will degrade. Okay, so that polyurethane by itself is thermoset. So people try to develop a thermoplastic polyurethane. That's why, and this thermoplastic polyurethane have this stretchiness. Okay, so this TPU, we call it thermoplastic elastomer, because elastomer here, because when they make this thermoplastic polyurethane, they found that this polyurethane can be stretched like a rubber or silicone. So TPU is example of thermoplastic elastomer. Okay, it's not many elastomer thermoplastic, but this is one of it. Most elastomer is thermoset. Okay, so that is about the elastomer. So that's about the elastomer. We learn about rubber, silicone is a thermoset elastomer, and we learn also about TPU, thermoplastic polyurethane. Okay, properties of the silicone and type of the silicone. Now we talk a little bit about the effect of plastic to your health. Let me this thing. Have you heard before the BPA? BPA free bottle, BPA free container, and so on. The word BPA. Okay, when you go buy any container, sometimes you will see they put a label BPA free. What is BPA? BPA stand for, okay, BPA stand for bisphenol A. Okay, that's a chemical lah. It's a precursor to many plastic. Meaning that in order to make certain plastic, you need BPA. For example, in order to make epoxy, you need BPA. In order to make a CD or DVD, you need BPA. CD made from polycarbonate. Polycarbonate. Example of the polycarbonate we learned before is CD or DVD lah. CD and DVD. Example of epoxy, the one that you see before lah. The one with the hardener and also resin. So in order to make this epoxy and polycarbonate, they need to put BPA inside. Okay. But BPA is quite what we call, this BPA, people call it as endocrine disruptor. What does it mean is that the BPA itself, it can mimic the hormone inside your body. Endocrine means that the hormone system in your body lah. So endocrine disruptor here, what does it mean here? This BPA, if you ingest it, it will try to mimic the hormone inside your body. Okay, they try to sort of like camouflage itself like a hormone. So it will try to mimic, especially it will try to mimic the estrogen, the hormone for the female reproductive system. Okay, so now you have two things. You have the, for example, for the female, you have the estrogen and also the BPA if you ingest the thing. So that BPA will mimic the estrogen also. So you have the two things, the body cannot tell the difference. Okay, so that's why they call it endocrine disruptor. They will mess up with your hormone production in your body. It will mimic the hormone itself. Okay. So, and this lead to the cancer and so on lah, whatever the thing. Okay. If you use BPA in something that is you don't eat, then it's okay. For example, if you use BPA to make a CD, DVD, that's okay because you don't ingest in your body. The problem happens when you make a container or a bottle using a BPA, using a like precursor like a BPA. For example, you have the bottle, and then you have this bottle is made from, let's say, polycarbonate, whatever, and then you have some BPA inside. Okay, when you expose this bottle or container with the heat, this BPA can leach out. We call it leach out. When you have heat exposed to this container, the BPA can leach out. The term is leach out. Leach out. That's why when you buy a plastic bottle, water in the plastic bottle, you put in the car, and the sun is shining very hot, then normally it's advisable for you not to drink from that bottle, because regardless, even though BPA or not, let's say you have, for example, the normal bottle, normal plastic bottle, typically made from the PET, even though PET doesn't have BPA inside, but this PET is still can leach out some of the what we call is thing inside the PET can leach out. The chemical from the PET itself can leach out lah. Okay, even though they doesn't have any BPA inside, but other thing can leach out also. So normally plastic, as we said before, one of the problem with the plastic is that the temperature is it cannot sort of like sustain very high temperature. If it reach certain temperature, then the rigidity or the mechanical properties of the plastic will be compromised. So when that compromised, it can leach out. So if you have water here and you have sun here hitting this bottled water in your car, it's better not to drink this thing lah, because whatever make inside the PET can leach out. Okay, but looking at the BPA, that also can happen lah. When you normally, for example, baby bottle, normally you use when you want to make milk inside the baby bottle. Let's say this baby bottle. If you have milk inside, normally you will warm it. You not give a cool milk. Normally you warm this milk with the bottle itself. So this warming up will cause this to compromise. If you have this BPA inside, then the BPA can leach out. And then when it's leached out, it can goes inside your body and mimic the estrogen and disrupt your endocrine system. So that's why people said if you want to be safe, use glass. Okay, use glass because glass doesn't have this thing, all this thing. But the disadvantage of the glass is that the glass is heavy, easy to break, and so on. Okay, so that's about the BPA. Sometimes you see, let's say you go to the to the market, and then you don't want to use plastic. Let's say you want to buy a tomato can in a steel can. Let's say you want to buy, you don't want to, because the tomato ketchup you can buy in the plastic, okay, tomato. Or you can buy in the steel can. Let's say you don't want to use this because you're afraid about the BPA thing. You use the steel can, but still, inside the steel can like this, okay, you still have something. It's not 100% stainless steel. This is stainless steel, but inside that, you will see the color is different. So they put the epoxy lining. Okay, if you pass around, you can see there are epoxy lining, like a plastic there. Okay, the reason why they put epoxy lining inside this thing, if you see inside this thing, they have the epoxy lining. Epoxy lining. The reason why they put epoxy lining inside the tomato can is because tomato is basically acidic, and this acid can sort of like corrode the what we call the metal. It can corrode the metal. even though that is stainless steel, because stainless steel normally doesn't corrode in the normal environment, air, whatever, it doesn't corrode. But when you put it into acidic environment, then it can sort of like fasten the corrosion of the stainless steel, even though the name is a stainless steel, because the acid can penetrate. So that's the reason why they put the epoxy lining. Okay, so when they put the epoxy lining, it will prevent this metal from corrosion, and then this metal will not go inside the tomato can, because tomato itself is acidic. The problem now, they use epoxy, but the epoxy, as we learned before, have the BPA. In order to make an epoxy, you need to use BPA. So now, even though you can save yourself from the heavy metal, but you will have this BPA anyway. Okay, nowadays, most of the can, they use not epoxy anymore. They use acrylic and polyester. Acrylic or polyester? Polyester. Nowadays, instead of using the epoxy, they use acrylic and polyester as a lining inside the tomato can. But still, 10% of canned food in the world still have this BPA, the epoxy lining. Okay, so that's the thing. So that's where the BPA, you can find the BPA. Sometimes you will see the BPA, the BPA can also manifest itself in things that you never think there is the BPA. For example, let's say this thing, this cash receipt. When you go to buy something, go to the cashier, you get the cashier give you the receipt. Have you ever seen the receipt run out the ink? What they do? They change this thing, right? They don't change the ink, right? Because they don't have ink for the cashier register. This is basically a thermal paper. Okay, this thermal paper is not any normal paper. Meaning that thermal paper, what does it mean by thermal paper? If let's say I have this, I try to sort of scratch this thing, you will see the color change. This is what? This is not this thing. I think this lah. It's not really good. This one. So if you use your what we call it, your nail and try to scratch, you will see the color blacken. What happens is that when you scratch, it creates heat. So the heat react with the dye inside, and they use BPA to develop the dye. Okay, that's why this receipt is also one source of what we call BPA contamination in the world lah. So you can try to scratch with your what we call with your nail. You can see the color darken lah, because that is not a normal paper. That is just same like this. It's just thermal paper. The name is thermal paper. Okay, so I put here thermal paper. Thermal paper. Okay, so let me put here present BPA. Difficult lah to use this. Okay, let's say I put here the presence of BPA in thermal paper. Okay, all. Okay, so you see this one of the article that say that you see the highlight lah. So this is what we call the journal article lah. Journal article. So the presence of bisphenol A in the thermal paper. Okay, so you see the highlight only lah. Over 200 thermal paper samples were analyzed. So bisphenol A was found in 99% of the examined receipt worldwide. Meaning that is sort of like common contaminant lah of the BPA in the world lah. So this BPA is used as a color developer to promote the dye lah. Bisphenol A is used as a color developer in the thermal paper. See this thing. After the heating process, react with the whatever blah blah blah. So that thermal paper, the receipt, the cash receipt that you receive when you buy something is also the source of the BPA contaminant in the world. So yeah, that's the thing lah. So I think that's cover up this part. So we focus on BPA, how the plastic and the health, your health relate with each other. So we learned that plastic can leach out, and we focus on BPA. What is BPA? BPA is an endocrine disruptor. You can find the BPA when you use epoxy, polycarbonate, and so on lah. There are many more, but this is the most common lah. And even though you buy the can steel, you can still can avoid the BPA, because if the canned food use epoxy lining as their lining, then inside this thing you have BPA. Plus, you can also see the BPA presence in the cash receipt when you buy something, because BPA is used as color developer in the thermal paper. So that's conclude our polymer part lah.